question 6, there's a lot to do here. But basically, when we want to know the position, we want to use an s equals ut plus half at squared. And let's figure out what we know. The position s is when it's off the top of the screen there, but when it hits the ground. And when it hits the ground, we know it's gone 64 meters along and it's gone down 0.8 meters. So s is 64 minus 0.8. U is actually what we're trying to find out here. Use the initial velocity, which is PQ. T, you're told it takes 4 seconds to do that, so that's times 4. Plus a half the acceleration due to gravity, 0 minus 9.8, times by t squared, or 4 squared here. So we just look across the top bit there, you can see that, of course, this bit's all 0, so we've just got that 4p is 64. So from the first bit, we can see that p is 16. That's 64 divided by 4. Now, if you go along the bottom bit, we can find out what q is, and q is going to be, look, just tapping all of this in. So we've got minus 0.8, half of 16 times minus 9.8, put that over there, and then divide by 4. And when you tap all of that in, he says quickly, grabbing the calculator, you're going to get 19.4. So there's what P and Q are. To find out what the initial speed of the ball is, the initial speed of the ball, we're just going to square root those two things. So this was its velocity, and so the speed is the square root of 16 squared and 19.4 squared, and so the speed is 25.1 meters. And the tan alpha one as well. So here's alpha over here. We now know that P is along is 16 and up is 19.4. And so the tan of alpha is 19.4 over 16. And we could just cancel that down a tiny bit to make it look a bit nicer. It's 97 over 80. Lots to do in part D as well. Part D says, for how long will it be over 5 meters above the ground? Well, we already know it's 0.8 meters above the ground to start with. So we want to know, when is this journey here? So we're now looking at an S again, but this journey now is 19.4 times t plus a half 9.8 t squared. And what do we want it to be? Well, we don't care what that one there is, but we do care that this one needs to be, well, it's above 5 meters, already got 0.8 meters there. So here I want 4.2 meters. 4.2 plus the 0.8 makes the 5 we wanted. So what I've got here is a quadratic equation to solve, just along the bottom. So minus 4.9 t squared. If you solve that quadratic equation, then you're going to get two answers. When is it actually equal to 5 meters above the ground? And so the two answers you're going to get are 3.72, and the other one is 0.2348. So this one's on the way up, this one's on the way down, and the question is, how long is it above the 5 meters? So the difference between those two is 3.5 seconds. The last bit is your modelling assumption question, and the modelling assumption sort of what can be taken into account to make the model better. Usual answers for this is wind or spin or the size of the ball. Pick one of those.